Hey, welcome back, and in this video we're going to give an introduction to graph databases and in particular neo4j, which is one of the most popular open source graph databases in existence today. And we're going to get pretty hands-on with neo4j, so we're going to show you how to install it, we're going to create our own graph database, and we'll talk about a couple of the use cases that you would particularly use neo4j for. And at the end of this, you'll be able to pick up neo4j for yourself and then go ahead, create your own graph databases and solve your own business problems. So the first thing we're going to do is going to install neo4j in our local machine. What I'm going to do for the sake of cleanliness is I'm going to use Docker to do that installation, and it's pretty simple to get it installed in your local machine. You can just type in docker pool neo4j, and then that will do a download. Now, what you're going to see in my machine, because I'm running Apple Silicon M1 chip, you're going to see a no matching manifest for Linux ARM v8. And that's because neo4j doesn't have an ARM64 image that would work with the Apple Silicon M1 chips. Now, that's really easily resolved. All you're going to do is add in -- platform Linux AMD 64. And then what will happen is Docker will pull the AMD 64 version and Apple Silicon can run that in compatibility mode and everything will be fine for Docker. So if we return that, then Docker's going to do a download. You see I've already got it installed, so that's fine. But if on your machine, if you haven't installed it before, it'll take a few seconds to install that. And then if I do Docker images, you will see that neo4j is sitting on my machine. I've pulled the latest one, and that was from 11 days ago, and it's a sort of 600 meg or 559 meg image there. Now that I've pulled neo4j onto my local machine, I need to just run my Docker image. And if you look at my screen there for a second, you will see the command is pretty simple. It's docker run. You have to specify the port, so it's -p, and in this case 7474. And 7687. They're the two ports that you need to expose to make that work. You see I'm running it as -d, so it runs as a background process. And then I'm setting the username and password to neo4j test. And then, of course, I'm using the latest neo4j image, the one I just pulled. Now, of course, because I'm running Apple Silicon, I have to do the -- platform Linux AMD 64. But if you're not running Apple Silicon, you don't need to do that. You can just do a straight Docker run. Now, this will install neo4j as a ephemeral container. So if whenever I start that up, and then when I kill the container, any data that I've saved into that container will get lost because it will be destroyed when I destroy the container. If you want to persist your data, then you can see here that you can set data logs where your plugins are as sort of command line inputs. And you can specify somewhere on your machine where that data can be stored. And therefore, when you start the container up a second time, it will have a save file. It will have all the data stored outside of the container. And that will allow you to restart where you left off. In our case, I'm just going to run it, and whenever my container dies, then I lose my data, and that's fine for me. But you can choose what scenario works for you the best. So if we just take that command for a second, I'm going to copy that, and I'm going to put that in my terminal, and we'll just hit run, and that will start off neo4j on my local machine. Now that neo4j is up and running, I can just quickly check it's running in Docker by typing docker ps, and you will see neo4j latest is running in on my machine. So if I just open up my browser, and if I go to localhost 7474, we'll just hit return, you will see I am presented with a connected neo4j. So you see neo4j is running on my machine. And for the username and password, if you remember, it was neo4j is the username and test was the password. And then if I hit connect, and if you give it a second, it will log into neo4j, and we are up and running. If it's your first time using neo4j, there's lots of really cool tutorials that you can mess around with. So there's guides to CYPHER, which is the query language. I'll talk about that in a second. There is data set. So there's like a movie data set that's built in, and there's guided tutorials that you can play with. So if you want a sort of guided tutorial to neo4j, you can do that. What we're going to do, though, is build our own neo4j database for a sort of real world scenario that we might utilize. So the first thing we're going to do is start interacting with the graph database, and neo4j uses a language called CYPHER, which is their sort of query language for interaction with the graph database. And we'll start using a couple of these commands as we start to interact. So if you want to return all of the nodes that are in the graph database, then you can basically run the match command, which says it's like a query. It says just find me anything that matches the criteria that I have. So I'm going to type in match n, which just essentially means I'm searching for anything of n, which is of type node. So it's going to basically return anything. And then if I just type in return n, so the node type that I'm matching, and if we just hit return, you'll see that there is nothing in my database at this point. So the first thing I'm going to do is I'm going to create an empty node on the graph, and then we'll return that. It won't have a type at this stage. It's just going to be an empty node. So we'll just type in create an n, and in this case, because I've not specified a type, it's just an empty node. So if we hit return, you'll see created one node and it took 51 milliseconds. So if I just type in the command that we used the last time, which was match n, return n, then it will now return my empty node that I created 2 seconds ago. So if we hit return, you'll see it returns a node, and it's not got any type, there's no relationships, and it's in my graph. And if I wanted to create another node again, I could just do the same thing. So create n one more time, we'll just return that. You see it's created another node. And then if I run this query again, you'll see I now have 2 nodes on my screen. So that's us up and running. It's our first version. If I want to delete these nodes, then I can run the match n and then just return delete n. So I'm saying find me a node of any type and then delete any of those nodes that you find. So if I just run that, you'll see it's deleted 2 nodes. I created 2 nodes before. And then if I was to run this query again, it's a no changes, no records, right? So I've deleted those nodes. Of course, if I was following my social networking example that I gave before, then what I'm going to do now is create a person. So what we want to do is create a node of type person. So what we would do there is say our node of n, and we will say the type is person. So the key thing that we're doing here is we're using that. Before, when we were creating an empty node, it was just n, and now we're saying we've got a colon there, and then we're saying the type of the node that we want to create. In this case, it is person. So we just run that as we did before. You'll see it's added 1 label, 1 node. So my node has got a label of type person. And if I was to run that match n again, and you will now see I have a node and it's of type person. So you see at the bottom there, it's got a color of pink, and it's of type person, and it's got ID 0. So if I wanted to create another node, I'll just click on and say create n person again, and you will see if we run the match again, I've now got 2 nodes. So now I've got some nodes on my graph, and maybe I want to give them some properties. So let me just delete those nodes again. So we'll type in match n, and we'll delete n, and then they will delete those 2 nodes. We'll get rid of that, and you'll see that I'm back to having an empty graph. So what I'm going to do now is just add some labels onto the nodes like we did before in our social media example. So we'll say create, we'll say n is of person, and what I'm going to do is give them a name of Chris. So how that works is I use these brackets, these curly brackets, and then I just say what the name is. And you see it's a very similar format to JSON. So it's, and I can add any other sort of properties I want in there. So maybe I'm going to say favorite color, and that could be blue. Actually, I was orange before, wasn't I? I'm changing my favorite colors. And then if I were to run that again, you'll see it's now created that. And then if I run my match and run the graph, you'll see I've got the Chris person that is now created, and you see the favorite color is orange and the name is Chris. And of course I can take this and I can add some new people. So I'll say Jenny, and favorite color is blue, and then we'll run that, and we'll maybe say Jemima, and favorite color is green. And we'll run that again. And then if I run my match, you will now see I've got Jemima, Jenny, and Chris. And they've all got different favorite colors. So now that we're comfortable with creating some nodes, actually, let's create a couple of other different types of nodes onto our graph. So maybe in this case, some of these people are going to go to the same schools or different schools. So why don't we create a school node in this case? So let's do a create, and we will say n is of type school. And we'll say the name of that school is maybe going to, let's say they go to LSU, for example. So we'll create the LSU school and we'll just run that. And I've created one node, one label. And if I was, and let's add another school there as well. So let's maybe have let's have Ohio State as my school there. I don't know why I put capital letters there. So let's put Ohio State. So that is now run as well. We'll close that. We'll close that. And then if I run the match n return n, and you'll see I've now got LSU and Ohio State, and we've got Jemima, Jenny, and Chris. Very cool. So we've got 5 nodes on my graph there. And as you see, as I create different node types, it's given it different colors, so it's easy to identify. And what we can now do is even run different commands as well. So if I want to just see one type of a node, so let's say rather than returning all of the nodes, such as match n, return n, if I wanted to just see the persons come back, I could specify that in my query. So I can type in match n, and we will say of type person, and then return n. So if I run that, you'll see it's only going to come back with the person objects. And then if I was to change that and then say I want to see schools only, we run that, and you see it returns only to schools, so Ohio State and LSU. I could also limit. So one of the other things I can do is if I want to limit my results a little bit, then I can just limit them as well. So if I take this match n return n, and I can type in match n return n as we did before, but I want to limit it to 3 nodes or 4 nodes maybe, I can just type in limit and how many nodes I want to return, and then return that, and you can see it only returns 4. And again, I can sort of query this here. So if I want to, let's say, restrict it to just one type, so let's say I only want to return schools, I only want to return 1, then it will return that as well. So the limit command is quite useful. So now that we can create nodes and labels, what we're going to do now is create some relationships in our graph as well. So in order to create a relationship, what I need to do is, first of all, is find the 2 nodes that I want to relate. And then how I'm going to do that is using my match command again. So I'm going to relate Jenny to the school LSU. So I will type in match. And this time I'm going to use S as my variable, and I'm going to take school. So that will be LSU that I'm going to return. And I'm going to also get P for person. Now I'm going to do a multi-line statement in this case. So I need to type shift and return so I can be multi-line. So what I want to do now is only return the LSU school, and I only want to return Jenny. I don't want Jemima or Ohio State or Chris to appear, so I need to introduce a where clause. So where I'm doing that match, I want a school and a person. I'm now going to restrict it in this where clause, so it only returns the folks that I want and the schools that I want. So I'll type in where. I'm going to type in s.name, and that is going to be equal to LSU. And so that will mean it won't return Ohio State. It's only going to return LSU. And I'm going to want the person, and the name is going to be equal to Jenny. And actually, before I create the relationship, if I wanted to, I could just return them in the graph. So if I do return S and P and hit return, you'll see it returns Jenny and LSU. So it's not returning anything else. So what we're going to do now is create a relationship between Jenny and LSU, and the relationship is going to be studied at. So Jenny studied at LSU. And how we do that is, well, our match query is already returning LSU and Jenny, so we need our match statement like we did before, but rather than returning the nodes, we're going to create this relationship. And we do that by typing in create, and we need a bracket again. So in this case, I want the relationship to go from Jenny to the school, so I need P for person. So in this case, it's Jenny it's going to return because that query up here has restricted that to Jenny. So, and I'm going to have a dash, so a minus sign. So I'm creating this sort of arrow. It's going to look like an arrow, which you'll see in a second. And then I'm going to create, so I put some square brackets and I'm going to put in the relationship type that I want. So I'm going to put STU as the variable name. And this time I'm going to have my relationship as studied at. So we'll just type in studied at. And then to complete the relationship, I'm going to put another dash at the other end of this, so another minus sign, and then I'm going to put the greater than symbol. So as you can kind of see, it forms an arrow. So this is P, right? Person, this arrow, and in the middle, this studied at, and then the final thing that I need is S for school. So you see P studied at school, right? And if I hit play here for a second, it creates that relationship. Let's just copy that for a second, and then we'll close it. And then if we run the play button again, you will now see Jenny studied at LSU. So we've created that relationship. And of course, I can add more relationships if I want. So if I want to have Jemima go to Ohio State, then I can just change this query here. So we'll say Ohio State, and then we can run the same query again. And now if we run that, you will see that you will see that Jenny studied at LSU, and you will see that Jemima studied at Ohio State. And then I could maybe have Chris study at LSU again. We'll run that. And now we've got two people who studied at LSU, so Jenny and Chris. And then you see Jemima studied at Ohio State. So we're building up these relationships quite quickly. It's really good for networking. It becomes really easy to visualize. And I can extend this even further. So let's add in the friend relationship for a second. So what we're going to maybe do is so we'll have maybe two persons in this case. So we'll say maybe I'll have P1, which is person, and we'll have P2 as a person, and we are gonna say Jenny for P1, and for P2 we're gonna say Jemima, as we did before. And this time, rather than the friend relationship being, we'll create the relationship there. And rather than the relationship being studied at, they're going to be friend. So that is created. And if we run that here, you now see Jenny is friends with Jemima. Now, I think that Jemima should also be friends with Jenny, because I think it's weird not to be. So I am just going to modify that slightly. We'll do P2 to P1, and then we can have sort of a bidirectional thing. And then if we run that, there we go. That's nicer, isn't it? Jemima and Jenny are friends with each other, and I like that. Yep. So there we go. Jenny and Jemima are now friends with each other. Jenny went to LSU and Jemima went to Ohio State, but they are friends. And what we could now do is make Chris friends with Jenny. So let's do that. So we will say P1 is Chris, and we will set P2 to Jenny. We will run that for a second. And then if we just run this, now Chris is friends with Jenny. Let's make Jenny friends with Chris also, and we've got lots of lovely friendship relationships there. And we can sort of glean from this that Chris studied at LSU, Jenny studied at LSU, they're both friends, and Jenny is friends with Jemima, and Jemima studied at Ohio State. So we can get into this idea that if Chris wanted to meet Jemima, for example, then he could talk to his friend Jenny, and Jenny, who's friends with Jemima, would be able to interact. Another example could be if Chris wanted to know somebody who went to Ohio State, then you can see from the kind of map there that, you know, if he spoke to Jenny, Jenny's friends with Jemima, Jemima went to Ohio State, and therefore you can get an idea of who of Chris's friends went to a different school, in this case, Ohio State. So as you can see, as these networks get larger and larger, it becomes more powerful and you can start to form these connections, and they really have some fantastic use cases. So I think we're done with this example, and I think we're going to do a more complicated example in a second. So what I want to do is clear my graph, right? I want to clear my graph database and make it empty. So if I wanted to, if I type in match n, delete n again, we're going to see a problem occur. So let's do that. So I'm just going to run that. And you'll see it says cannot delete node 0 because it has relationships. You must first delete the relationships before you can delete the node. And that is true, right? So if you are wanting to get rid of nodes, you have to get rid of the relationships first. So the sort of thing that I would need to do is find that relationship, delete the relationship, and then I could delete the node. If I wanted to be super lazy, which I'm going to be in this case, then I can type in match n, and then I can type detach delete n. And what that will do is delete the relationships as well. And then if I just run that and then hit play again, you can see it's gone. So social networking is kind of interesting, but I wanted to run a more complicated example. So what I thought would be cool is let's take a supply chain example, in this case, a software supply chain example. And what I want to do is try and represent something like Docker and even the neo4j image, but represent that within a graph database. So I've created one a little bit in advance, and we'll sort of just copy a couple of these things in and we'll build up the graph as we go along. So what we're going to do now is start building up a representation of this Docker estate in my graph database. So the first thing I'm going to do is I am going to create myself a container registry. So if I just type in this, we'll hit play, and we can return match. And you'll see I've created a node called container registry, which is Docker Hub. So that is where I got my neo4j image. If you remember at the beginning, I got that from the Docker Hub container registry. The second thing that I'm going to do now is, because it's an official image, then Docker Hub has a representation, or Docker in general has a representation where everything underneath the container registry has to be in an organization. So the official Docker Hub organization for official images is represented as an underscore. So we'll just return that. So we now, if we run match again, we've now got a container organization and we have a container registry. So the next thing that we're going to do is create some repositories in Docker. So a repository is a storage area for a particular image. So the repositories we're going to create is going to be hello world. So there's a hello world Docker image that exists. There's going to be neo4j, which is what we installed earlier. And the other one would be node, which represents the Node.js image. So I'm just going to run that, and that's going to be created. And you'll see now I've got my hello world repository, my neo4j, and I've got my Node.js repository. And I've got Docker Hub as my registry, and I've got the official images underscore as my official image. And now what we will do is we'll create some relationships. So what we want to be able to do is have the container organization related to our container registry. So in this case, the official image is going to be the underscore organization is going to be related to Docker Hub. And then I'm going to relay all of the repositories, so neo4j, hello world, and node, to the official images organization. So I'm just going to create all of this. We're going to copy that into here. And this is just exactly what we did earlier, right? Which was we did the match. We're matching registries and organizations, and then we're creating relationships between these items. And so it's exactly what we did before. So I'm going to run that for a second, and then I'm going to close this, and then we're going to hit play. And now you will see that that this official images, this underscore, is related to the Docker Hub, and the relationship is of registry. And you can see organization, neo4j, hello world, and node all sit under the official images registry. So we're building up this sort of software supply chain representation of Docker. So what I'm going to do now is take the actual image and create that as a node on my graph database, and then I'm going to relate that to the repository. So that neo4j image that we installed earlier, we're going to create that as some nodes. So I'll just paste that in here, and you see the node type is container image. And that digest represents what that image is. And you can see it's an AMD 64 OS architecture. And you see another property that I have is the size of the image. And then I've done the same for another container image here. So that gives you a bit of an idea of what these images look like. And if I just hit play, it will create those nodes, and that will now appear in our graph. And there, because I haven't created any relationships at this stage, they're just sitting there on their own. And actually, for a bit of fun, if I was to just Google neo4j Docker Hub, and we click on here, and if we click view available tags, if you look at there for latest, you'll see 2377. OS Arch Linux AMD 64 size 338. And then if we come back onto my machine, there you go. So 237, that's the actual digest and the same OS architecture. And there's the image size. So it's a real representation of the neo4j image there. So what I'm going to do now is relate these images to the correct repository. So if we come back into VS Code for a second, I'm just going to select these relationship things, and all you'll see is exactly what we did before. So I'm just matching images to repositories. I'm saying what repo I want to relate it to and which image I want to relate it to, and then I'm just going to create a relationship. So in these cases in Docker, relationships are represented as tags. So I just say what a tag is, and then I put a property against that relationship, a label against it. So in this case, 425, which represents the version. And of course, I've also put a latest one there as well. So if I hit play, that's created all of that. And then now, if I look at that, you can see I've got two tags against neo4j, digest here and digest here. And if you look at this tag, this is the enterprise version, and this is the and this is 425 enterprise, and this digest here is 425, and this one is the latest. So I'm now building up this representation of my software supply chain. So that very same neo4j image that you created earlier on your local machine, we're now starting to represent in this identity graph. And that becomes really powerful, as we'll talk about in a second. And then the last thing that I want to do is actually, if I come back to this, you will see that the neo4j image was pushed 12 days ago by this Doi Janky user. So what we want to do therefore is represent them in the graph. So I will create the user. So let's come back into neo4j for a second, and I'm going to create a user called Doi Janky, and then I'm going to relate that image digest, and I'm going to create a relationship called push by. So you would see for each image that you create, you'll see which user did the push. We'll just run that, and then we'll run match again, and now you can kind of see that these two images were being pushed by this one user, Doijansky. Why is that useful as a real world scenario though? Well, if you think about it, as I'm creating my own software supply chain, I could get really complicated in my graphs, right? I could have more and more images in my supply chain. I could have my CI/CD pipelines represented. And I could really build up a very detailed estate of what my Docker image estate looks like and how my CI/CDs relate to that. And this would actually allow you to discover any potential problems in your architecture. So a good example is, let's say, so maybe, for example, you're not using Docker Hub as your container registry. Perhaps you've got your own private registry. Maybe you're using GitHub packages, or maybe you're using Quay.io. And therefore, in your architecture, you don't want any images coming out of Docker Hub. You want everything to be in your Quay.io. So you would maybe have this graph representing every single image in your estate, and that's great. And then you could see that relating back to Quay.io. But then if somebody came along and installed something
maybe from Docker Hub, a public image, then if you built up this sort of identity graph and you automatically created this, then you'd be able to look at it and say, oh my goodness, why have I got images from Docker Hub? That's not meant to be there. And you'd be able to find that very, very quickly. So that could be a good way of looking at your supply chain. Of course, the other one is a good example is if you think about things like typo squatting attacks. What a typo squatting attack is if somebody gives a wrong name. So let's say rather than neo4j, there is a nefarious image called neo4k, and one of your developers automatically installs that by accident, then that repository could appear on your graph. And you would see neo4j and you could see all the containers that use it, but then you would see this neo4k thing appear and you go, oh my goodness, why is somebody using neo4k? And therefore you could have some rules that stop these things appearing in your software supply chain. So that could be a really good use case. Then of course the last one is what if a user becomes compromised? What if a new user appears? So in this case, all of these images are being published by this Dojanki user, right? Which is cool. And maybe your images are published by a certain user, maybe Chris Hay UK or Fred or Jemima or Jenny. But let's say somebody publishes a Docker image. They've got access and it's a different user. Maybe their name is Banana or something, right? And then you would look at this and you see all of these images are pushed by Dojanki or Chris Hay UK. It's normal, but then this Banana user appears out of nowhere. Well, that would be easy to see and query and understand that. So now that I've got quite a complicated example of my Docker estate, I can start doing some really cool queries. So maybe what I want to do is find only the container images that are marked as latest for neo4j. So how would I do that? So the first thing I would do is I would use the match command as I did before. And in this case, I want to return the container repositories that are named neo4j. So we will just type that in and you will see I'm not giving container repository a variable in this case because I'm not going to do anything with it, but this match is only going to return those container repositories named neo4j, which this one is. So if I had lots and lots and lots of other repositories kicking in there, so I've got node and you see I've got hello world, none of them are going to be returned. It's only going to pull the neo4j repository. These two will get ignored, right? So that's fine. So the next thing I want to do is once I've got neo4j, I want to return the container image that is related to neo4j with the latest tag. So how I would do that is I would use that arrow syntax that we use when we were creating the relationship. So I would do a dash as I did before, and I would do the square brackets. I'm not going to give the relationship a variable because I'm not going to do anything with it, but I'm going to set that to latest, and then I'm going to do another minus sign here and a greater than, so it creates that nice little arrow. So it's anything that is related with the tag latest from container repository to container image. So we are now going to give it a variable. So I want to, because I'm going to use that a little bit later. So I'm just going to say image, and it's going to be of type container, and it's going to be of type container image here. So we'll just type that. And then I'm going to go multi-line for a second, and I'm going to return my images. So if I hit play on that, for example, you see it's only returning 23711A1. And of course I can do some really kind of cool stuff there as well. So if I rather than looking for latest, if I want to find things with a specific version, I can do that as well. So let's say rather than looking for the latest tag, I'm gonna look for a tag, and I want to find tag of name enterprise. Yeah, so if you remember in this example here, this tag here has got the name enterprise. So if I run that and then hit play, you see it's now returning 646B, which is this one. So it's full in this path. It's ignored latest, it's ignored this one before. So as you can see, you can run some really kind of complicated queries and start traversing things very, very quickly through the CYPHER syntax. And of course, there are other use cases. You can kind of imagine how this is used in things like banking for fraud, for example. As you represent people in your graph database, and payments as relationships. And therefore, if somebody new appears, so perhaps there is a fraudulent account of some sort, or a fraudulent person, or maybe you just mistype a payment to an account number that you've never sent before, then if it's not in this graph, if it's a relationship you've never created before, so it'd be easy for the bank to detect that there is an issue, because it's a transaction that you don't normally do already, and be able to say, okay, actually, did you mean to send money to that person? And of course, it actually becomes super easy to identify things like fraudulent accounts, for example. So you can imagine these really complicated relationships where you're sending money from one person to another, and then maybe it all funnels into a single user. So maybe that's 6-7 relationships deep, right? So you transfer money to somebody, they transfer money to somebody else, to somebody else, to somebody else, and maybe you have 20 different accounts all send money to this central account. So it'd be easy to find this in something like neo4j, because you can start to traverse those relationships and discover many levels deep of where money is moving along. And therefore, if you wanted to find things like mules, or if you wanted to find things like money laundering, then this technology really helps you discover that. And again, that is something that banks are using today to do that. So this is the exact software, the exact techniques they're using to discover these fraudulent transactions. So hopefully you found this quite useful. And I'm hoping that you are imagining all your own use cases that you could use in your own business. And again, this technology is getting hot in things like e-commerce, for example. Anywhere machine learning or recommendations occur, it's getting super hot as a technology there. And I'm sure you're buzzing with your own ideas of how you could use this. But today, hopefully, you've got a pretty good idea of how to get started using a technology like neo4j and start creating your own graph databases. In future videos, I'm going to show you how you can then start doing things automatically. So using things like Node.js, for example, to start automatically creating graph databases from your code and building that up on the fly. Then I'll cover that in a video, and then I'll probably delve into other examples of how you could use neo4j for some of these other use cases that we've said. Anyway, I hope this has been useful, and speak soon.